everyone, this is my project for implementing C bindings for verkle-ipa. So yeah, I was mentored by Matsim from Constantine and Agnish from Nimbus team for the project. So yeah, talking about the project, how it all started, like I started on the project pretty late last month. So basically, the idea behind the project was the Constantine library provides a lot of cryptography primitives for Ethereum and non-Ethereum backends. So yeah, so the project basically was developed since there was a lot of client teams which wanted to leverage the cryptographic support for Verkle to integrate with theirs, as the performance provided by the Constantine and the Nimbus implementation of the Verkle drive was significantly good. So yeah, so that's why the way to use the Constantine library for integrating with other clients was to export the Verkle IPA implementation using the C bindings, and this is what the project was about. So how it all started was, so the first step was implementing the bindings for the Edwards curves and the Van der Wagen curves along with their operations. So yeah, this basically involved, since the Constantine library already had implementation of Van der Wagen and the twisted Edwards curves, but they were not exported through the C bindings. They have C bindings for some of the curves, like the elliptic curves or other Pallas and Vestas curve, but the Edwards curve and the Van der Wagen curves were missing. So the first part of the project was implementing the C bindings for these curves, and then since the Constantine code base is basically generic, like it is not protocol is specific to Ethereum, so the next step was to implement the Ethereum specific wrapper for the Verkle IPA implementation, and then exporting that to be available to other clients. And next was to integrate it with the client teams. So presently, I was involved in working alongside with the Besu team for integrating the Constantine bindings in their Besu native. So yeah, so how it went, so I started with implementing the bindings for twisted Edwards curves. So this involved all the operations they had, like the addition, multiplication, scalar multiplications, batch affine, and so the mainly the curves which were used for the Verkle here were affine and projective, and all the operations which were yeah, and the operations for these were basically needed to be exported. So the bindings were generated for the affine and projective curves, and then implementation of the Van der Wagen curve was also done in a similar way, where they had the scalar field and scalar field implementation, scalar field specific operations exported through the C bindings. So this first step was completed and was approved to be merged. And here's the PR for it. But there were some issues since Constantine is still not ARM compatible. So there were some issues which I was facing while working on like proceeding further with it, as there were some GMP headers which were not being able to, the Mac was not being able to find it. So like had to work on it with the Linux systems. So the next phase was to implement the generic, to make the Ethereum specific bindings for the Constantine code for Verkle IPA. So yeah, so this involved basically implementing the functions which were needed for to be integrated in the client architecture. So it was the proof, multi-proof, commit, and verify and multi-verify. So yeah, and exporting these through the export C pragma. So this PR is, so like this work is also done and it is open for review. Talking about how the next steps will go on. So yeah, there are a lot of problems which are arising due to the ARM incompatibility with the the Constantine. So first, like, we need to figure out if there is some way so that we can proceed on with the testings, and then test the C bindings with the test the C bindings for the curves and the verkle-ipa from the Constantine, and then finally integrating it with the client teams. So we have a Besu team with which the work is currently going. So there is a PR on which the work has started, but since the bindings were missing, so we need to implement, integrate it with that. And yeah, so this was all about.
Thank you very much, Richa. Thank you so much. Yeah. Any questions? Any comments for Richa? We have a ton of time to, yeah.
What problems are facing we're facing with the ARM specific? Is it assembly level code, or why specifically is there an ARM problem?
Oh, so there were some. There is a library GMP which is available in the C. So that requires the x86 architecture. So the linker, when I'm using it in the ARM architecture, the linker is not able to find the path. So I tried several ways, like including the exact path for the GMP, because GMP is in the system. So I tried including the exact path, and several other ways, like manually trying the linker to link to that GMP, but that didn't work yet. So I have to find other ways to see it.
Nice work.
Thank you.
Awesome. Any more questions? We still have a space. If there is any question, comment for Richa. Yeah. Yeah.
Is this one? Test them? Yeah. I was just wondering, can you say like what went really well with this project? Just in general.
Sorry?
What went really well?
So what went really well was, like, basically I got to know about the Constantine library. Like, on my part, like, for the learning was the mainly thing which I actually enjoyed on. And apart from that, while working on the bindings, like the verkle try was already implemented, so exporting those bindings were quite easier, because the bindings, like generating bindings, there was already a template which could be used directly to have the data types or the curves or the Van der Wagen or the associated parts to be integrated. And there were several segments of the code which needed to be modified because the library has a lot of links internally. So that was also easier because of the way the code is.
Awesome. Thank you so much again.
Thank you.
Yeah, give it up for Richa again. Thank you very much. Yeah, that was lovely. Yeah, and again, it's not